letter B gets into the specific rules for integration. It talks a little bit about Robert Henry Risch. He's an American mathematician. He studied at UC Berkeley. I don't know. I don't get too excited about all those. All right, so basic rules. So basic rules, if you integrate, take the integral of, integrate a constant, it's just your constant times x plus the constant of integration. If you have a power, your power rule, add 1 and divide. This is what we've been doing. Plus c. E to the x is just e to the x plus c. I will tell you this you have to be careful of. Normally you're going to rewrite where you move the x up, but because the derivative of ln x is 1 over x, that means the antiderivative of 1 over x is ln x, and people get caught by that, so be careful. Plus c, plus c, plus c. And this is what we were just talking about in letter A. Sine is negative cosine plus c, and cosine is sine plus c. And we just talked about this in letter A, so I'm not too worried about that. Okay, so let's just get into some regular problems. We're just going to, I always keep that constant while you're getting used to it, and then just simplify. You may get to a point where you can just simplify the constant in your head, you know what you're going to divide by, but I just always take add 1 and divide, bring down the plus, 5, add 1 and divide. This gets a little weird at first. Constants, but if you notice, the degree gets 1 higher for each piece, plus c. Now, the only one that needs to be reduced, simplified, is this first one, which is really just 1/2 x to the 4th. And this is our final answer. All right, so just like you want to rewrite with a power for derivatives, we also want to rewrite for integrals. So I'm going to keep this 5 e to the x. And remember, this is x to the 1/2 in the bottom, so we have to move it up. And that's 2x to the negative 1/2. So we antiderivative, integrate. 5e to the x is still just 5e to the x, your constant times the antiderivative of the function, plus 2x. When we add 1 to negative 1/2, we get a positive 1/2. When we divide by 1/2, you might want to flip it and multiply by 2. Plus c. Then to simplify, this doesn't change. And then this is 4x to the 1/2 plus c. Now, if you're just doing the antiderivative, you can just stop there. A lot of the times the book will rewrite x to the 1/2 as the square root of x, because this would be easier to evaluate when there's numbers here. So as an antiderivative, this is totally fine. When you're going to evaluate, you may wish to go a little further. And the last one's the easiest one. Sine is negative cosine, so that's negative 2 cosine. Cosine stays the same with the antiderivative, which is negative sine plus c. Now, 4a is probably the hardest one that we're going to do, because when there's powers here, The only powers that you, of functions that you can add, one, and divide are the ones that have just a derivative of a constant on the inside. When you see x's like this, you're going to have to simplify it first. All right, so first of all, this one is going to need a little bit more room. How do I expand this, anything to the third power? The way I think of it, you can take this times itself 3 times, but you could also use Pascal's triangle. And remember, you always match the exponent to the second number. So you start with the first one, x to the highest exponent. I'll just bring that down. And it will alternate in sign because that's negative. 3, the x goes down in the exponent. And then we start raising the second part up. Plus, next coefficient, the x goes down, the 1 over x goes up, minus 1 times 1 over x to the third. All right, so this is using Pascal's triangle to expand this to the third power. I'm going to rewrite this a little bit more simply though, because I get negative 3. If I take x squared over x, I just get negative 3x. This time I'm going to have x squared on the bottom, so that ends up being 3 over x minus 1 over x to the third. So the hardest part, in my opinion, in this problem is expanding the original problem. So now we're ready to do the antiderivative. Power rule, add 1 and divide. Add 1 and divide. All right, this is where you have to be careful. This is the ln x, because when you have a single x in the bottom, so it's 3, that's our coefficient, ln x. This is always an absolute value because you can't take ln of a negative. Since this x has a power, think of that as x to the negative third. So we add 1 and divide plus c. Now in simplifying this one, I probably didn't give you enough room, but the next one's actually kind of easy. This is really the only piece that needs to be simplified. This negative makes this negative a plus. I'm going to move this back down to the bottom to be with the 2 and make that exponent a positive exponent. And this is your best answer. Okay. This one doesn't need so much room. If you were dividing by a single term in the denominator, we can rewrite this. I'm going to write this as x to the 1/2 over x plus x squared over x. It's kind of like going backwards from adding fractions. I'm separating the denominator into 2 different denominators, giving each term in the top its own denominator. And then I'm going to simplify this. If I have x to the 1/2 divided by x to the first, I'm going to subtract exponents, and that's x to the negative 1/2. When you divide bases, subtract the exponents. 1/2 minus 1 is negative 1/2, plus x squared over x is just x. So this is now written as a power, so we can just use our power rule. Add 1 and divide by 1/2, which means multiply by the reciprocal. Add 1, and divide, plus c. So this ends up being 6 x to the 1/2 plus x squared over 2 plus c. And that's it.